Okay, this is Dr. Morton. So here's what we're going to do. First, I want you to go down here and import SDK example. Click on the Freedom Board, go to Next, go to Demo Apps, not the drivers. On Demo Apps, sorry, don't click that, just expand it. And down here you'll see DAC ADC. Click that one. And then it should populate the name up here, and anyway, or give it a name and click Finish and you're good. All right, so we're going to cancel that. And then once that's loaded in, it should look like this. Freedom KL25Z underscore demo underscore apps underscore DAC underscore ADC. So it stands for digital analog converter to analog digital converter. And what we're going to do, go ahead and load this up, read this text, and basically do what it tells you. The one thing you have to do is put a wire between pin PTE 20 and pin PTE 30, which is the DAC 0 out. So you're going to connect the output of the DAC to the input of the ADC, and then it's gonna allow you to pick from about 4 different values, and it's going to show you the value. It's going to output that value for the DAC. You're going to read it in the ADC, and the ADC is going to print its value and convert it to the voltage, and then you're going to see how accurate it is, what the precision is. So just run that application. Then when you've run it, played with it a little bit, you're done, then that's fine. You will have to put it in a terminal window, and I think your choices are 1 volt, 1.5, 2 volts, 2.5, and 3 volts. And then anyway, it should you can pick these different ones, and then when you're done, you can hit 2, terminate the demo. Okay, once you get done with that, then we'll get rid of the README, and then what I want you to do is I want you to go up here. There is a static function that's placed here, and it's the static void DAC, ADC, and NIT. And so within this function, let's see. No, that's a proto. Oh, here it is. That's the prototype, but here's the actual function. Okay, and so you do have to modify this function, and where you should do that, we need to go down here. It's gonna create a pointer, and it's gonna create for both the ADC and the DAC. It's gonna then set up the default configuration for the DAC, and then it's gonna do the same for the ADC. Get default configuration. One of the problems with the ADC is we want to change this line in the default configuration. We want to change it from false to true. So what we're going to do here, this is just a comment, so that doesn't count. So what we have to do is, here's where it actually it gets the default structure there, and now it actually initializes the structure. And here's the, so what you have to do is just use this ADC 16 config structure with a dot, and then enable continuous conversion and set that equal to true. And then that'll take care of that. Now it'll just continue to trigger over and over again. Okay, so then we have the rest of the stuff we leave alone, and then in the main function we go down here, and the first thing we do, we go to the infinite while loop, and we're going to comment out this whole print and case statement all the way down to the end of it. And then you're gonna leave alone this ADC conversion flag, done flag equals false, and this ADC set channel config stuff here. You're going to leave all that, and then that's going to trigger another conversion. When the file thing times out, then the flag will be will no longer be 0, and so then it'll drop through here, and the DAC will then what we want to do is we want to add this line right here. And the way you can get this line, just go up and grab any of these lines here, copy it down, and instead of this voltage, DAC 3 volts or DAC 2.5 or whatever, put in the output of the A to D conversion, which is here, G underscore ADC 16 conversion value. That's the actual output from the A to D converter. So now what we're doing, we're totally reversing it. The original program, the DAC outputs a voltage, and the ADC reads it and prints out what it reads, so you can see how it compares with what it was supposed to, what it put up. and it's actually pretty accurate. Now what we're doing is we're going to take a signal generator, and we're going to make sure we set the period of the signal generator so that so we keep the voltage within the 0 to 3.3 volts. Most times the signal generator is going to have a signal that has its center points 0, and it's going to go plus or minus. So what you have to do in the signal generator is set the amplitude to 3.2 volts, a little bit less than 3.3, and then put in a 1.6 volt positive offset so that the whole thing varies from 0 to 3.2 or 3.3 volts. And so then that'll work with the PIC, with the KL25Z, and also with the scope and whatnot. All right, so once you get that set up, set it for about, 40 hertz. And then put that in to PTE, put that value in to the A to D converter. And then the A to D converter's results will internally be written to the DAC, and then the DAC's going to output what the A to D converter is converting. And we're going to display one channel is the actual signal coming from the signal generator, and the other channel is the output from the DAC, which should more or less match it. And then we're going to increase the frequency and watch and see what happens. All right. So you also like to have a terminal window. So here's my terminal window. I have a little picture. So here's my setup. These two pins right here, the inside row here, this is PTE 30 and this is PTE 20, and they're the extreme opposite ends of that inside row. And then we have to have a ground pin here, and we've got all of our grounds connected to this ground pin from the signal generator and also for the scope. Now my one scope probe is on what's coming out of the DAC, and somehow this ground came off. And then the other scope probe is on the signal from the signal generator. Now you can see, here's my signal generator. Oh, man. Oh, yeah, it's working. Oh, it should be. Let's see. Why? Oh, I can't, because it's not working. That's why. Okay. Oh my gosh, it's just so ridiculous. I swear, that is just so irritating. But let me fix it. So I'll pause this. Okay, so there's my scope. There's my signal generator sitting on top. Now, in a minute, I'm going to change the frequency of the signal generator, and we're going to watch the scope. And but you'll be able to see the scope really well because I have it in a window over here, and we're going to bring that up in the video program. All right, so I just wanted to show that, and then here's our setup with the circuit down there. You can see it's a bunch of probes and stuff. Here's my signal generator. Notice I'm putting one of the signals into PTE 30, which is this pin here on the inside row, and I'm using a ground that just came out, and it's this pin right here. And actually that's better than it's been. And then so I have the yellow. So let me show you the scope. Well, so we'll run it. Okay, we'll do this, and we'll hopefully run it, and then we will let it rip, and then we have to go over. So we have to go to the terminal window here, and I have to click on that, and I have to click character, and so then that starts everything running, and then I'm going to get rid of that so you don't. Well, I'm going to bring up the scope so you can see it. So here's our scope tracing, and what you can see then is the yellow, the green is the actual signal generator. The yellow is the scope. Now, if you look, the green is at 500 millivolts per division, and the yellow is at 1 millivolt. So that's why its amplitude is smaller. But if I change that over here, well, it's easier actually just to change it here. If I change it here, and I think it's this one. and I make it the same amplitude, you can see they pretty much overlay right on top of each other. But you can't see it very well when I do that. So what I'm going to do is I'm going to drop this back down so you can distinguish the difference between them. And now I'm going to start raising the frequency. And watch as I raise the frequency. So you can see the frequency on the scope. Right now it says 40, and so I'm gonna raise it up. So 50, 60, 70, and I'll change this a little bit. Now you can start to see some of the noise associated with each of the data points. And then we're going to keep going. And I'll change the horizontal axis again. And I'll go some more. So we're up to 110. Now you can start to see that my yellow signal looks discrete, especially if I go ahead and bump it up. You can see I have little stair steps. And then if I keep on going, now I'm at 500 hertz. Then you can see it's still tracking pretty nicely, but it's little stair steps now. It's not a continuous tracing. And then I'm going to get up to kilohertz, 1 kilohertz right there. Okay, still not too bad. My trigger level probably could be better. Let's see, where's my trigger level here? Yeah, it's a little better. Okay, and I don't know why the measurements are on there. Anyway. Okay. And then, so now I'll go up a little more. So that's at 1K. And naturally, maybe I'll advance a little faster. So 1.3, 1.4. Now you can see we're really starting to see, we don't have that many, we got maybe 15, 16 points across the signal. And then if we keep going, and every now we're getting a lot of jitter in our DAC signal, because every now and then we're sort of slipping a little bit apparently, so it's jittering along a little bit. All right, so you can see that it makes a real difference. And what did we get up to? Let's see. Well, I don't know. We're up to so we got up to maybe almost 3-4 megahertz, kilohertz rather. So that, that's not quite 4. There's 4. Now, if we did really good filtering, we probably could recreate our sine wave pretty well. Might be. There is a little. It's not too horribly noisy. So anyway, all right. So that is what I wanted to show. So we'll turn that off, and maybe we'll turn off our terminal. Okay, and let me go back to here. Okay, so that's the part I really wanted to show, and I also do want you to go through. I'm not going to do this in the video, but I want to go through a bunch of the structures and talk about it. And I'll probably do that in class a little bit, and I'll also hopefully write those changes up so that you can follow along in the lab guide. All right, with that, I'm going to quit.